In this video exercise, we'll demonstrate how to scan a protein for potential residue mutations and compare the relative binding affinity of two protein chains for each of the mutants. So let's begin by going to Tools, Protein Preparation. Then enter 1BRS and click Import. Now in this exercise, we will need two chains from this protein, so we'll head over to Review and Modify, then we'll click Analyze, and then we'll select chains B, C, E, and F, and then click Delete. So now we have a trimmed version of the protein with just two chains A and D. Back over in the Import and Process tab, we'll check on Fill Missing Side Chains with Prime. This is because the protein has some side chain coordinates missing in the PDB structure, so adding them at this stage performs a quick addition of the side chains. Refinement of the other locations will be done later. Now click Pre-Process. Looks like there are a few atom clashes being reported here. We'll ignore these as the clashes will be fixed later in the process. Now over in the Refinement tab, click Optimize in the H-bond assignment section. Optimizing the hydrogen bonding is important because X-ray structures do not usually have enough resolution to fix the orientation of terminal amides or histidines or the orientation of hydroxyls and thiols. Now click Minimize. Here a restrained minimization is done, which removes the atom clashes and relaxes the side chains and other modifications made to the protein. Now the results are added as a new entry to the project. We can click View Problems to verify that clashes are gone. So now the protein is ready for use. Let's go to Tasks, Residue Scanning, Perform Calculations. Then click Analyze Workspace. We'll choose the default chain A and click OK. Here the structure in the workspace is analyzed and the residue table is filled in with all the residues in chain A. Now let's select a few residues. Let's go with lysine 27, aspartic acid 54, asparagine 58, arginine 59, glutamic acid 60, glutamic acid 73, arginine 87, and histidine 102. Now we'll want to mutate the selected residues to alanine, so here we'll just click Apply. Notice that the selected rows are marked for mutation and the mutation is set to alanine. And notice that the text message at the bottom of the tab reads, "Will mutate 8 of 108 residues." From the Refinement option menu, choose Side Chain Prediction BB. This option allows for some movement of the backbone in response to change in the side chain. The rest of the settings can be left as they are. Now click the Settings button to open the Job Settings dialog box, then choose a host from the Host option menu. If you choose a multi-processor host, you can distribute the job over multiple processors. For this job, you can specify a maximum of 8 subjobs because there are 8 mutations, and so you can specify up to 8 processors. I only have 4, so let's choose 4. When you're ready, click Save and Run. When the job finishes, the Residue Scanning Viewer panel opens, displaying the changes in properties for each mutation and a graph of one of the properties. Let's choose Change in Affinity from the Graph Property option menu. Here the graph shows the change in affinity of the mutated chain for the other chain on mutation as a function of the row number in the table. Note that some mutations improve the affinity between the chains, while others destabilize the complex.